So parallel lines have the same gradient. Definitely highlighting that. We saw that on the warm-up from yesterday. And then I can see it right here that every one of these lines has a gradient of 3. So they're never touching, those parallel lines. All right, and then I have here perpendicular lines meet at a right angle. Maybe I'll use a different color. So that word perpendicular means at a right angle. That's like a normal word that even if you never do math again for the rest of your life, it's a normal word. You know what I mean? That people use, adults use. Perpendicular, getting at a right angle, like a T. Yeah? So it says if the gradients are m1 and m2, so let's say like 2 and -5 or whatever, and when I multiply them together I get -1, then they're perpendicular. So what does that mean? This thing says this gradient is -1/2. Can you see it? Because it's the m. And this gradient is 2. And so I have a sneaking suspicion that those meet at a right angle. So I'm going to do 2 times -1/2. How do you multiply a number times a fraction? How do you multiply a whole number times a fraction? You can, yeah, I would just put it over 1. And then you multiply straight across the top, 2 times -1, and straight across the bottom, 2. And that, in fact, is -1. And that's the rule. It says if m1 times m2 gives -1, then I know these are perpendicular. Now, this is how I like to think of it. I like to think of it is that they're negative reciprocals of each other. I'm going to write that down. Negative reciprocals. Negative reciprocals. Reciprocal, sorry. What does that mean? That means if one of the numbers is, if one of the gradients is 2/3, the other one is going to be negative, because that one's positive. This one has to be a negative, and then upside down. Okay? This means change the sign. This means flip it upside down. You want me to put it up? This means change the sign. So opposites, positive, negative. And reciprocal means flip it upside down. So what's the reciprocal of 5?
Negative.
Just the reciprocal. Okay, the negative reciprocal of 5.
-1.
-1/5. Is that all right? Okay, that's what reciprocal means, flipped upside down. So if the gradient, if they are negative reciprocals, that means they're perpendicular, the gradients. Does it matter what the C is? Does not matter. The C can be anything. In both, they can be different. Okay, let's try these. Ready? Here we go. It says decide if the graph of each pair of rules will be parallel, perpendicular, or neither. So I'm looking at gradient, right? So I'm going to write this gradient. That's what I'm trying to look at. So in A, I don't know why I'm writing with this pink pen, silly. In A, I have the gradient okay. The gradient of this first one is what? Let's just make it -3. I don't care if you put over 1, though. Okay, so y equals mx plus c. Okay, so the gradient is -3. And what's the gradient of this one? Are they negative reciprocals of each other?
Yes.
So I write, therefore, perpendicular.
So is negative reciprocals when they're not equal? And they're not the same?
Okay, ready? One of them is -3. The other one is positive, so the other sign, and upside down. Okay? 2 and 5 are not equal, but they're not negative reciprocals of each other.
Yeah. Does that mean they're like not parallel?
They're definitely not parallel. They're perpendicular. Okay? They're perpendicular because -3 times 1/3 is equal to -1. And you could type this in your calculator if you want. This is the rule that proves it. And I highlighted that rule upstairs in the notes. Okay, B.
So that's the same, the rule, that one that you just did is the same as like the negative reciprocal.
Yeah, that rule and this is the same thing, okay? Is that fair? I never really learned that rule when I was a kid. My teacher always just said negative reciprocals, but I get it now. Okay, here I go. So the next one, it's
How do you know it's perpendicular?
because when I multiply the two things together, I get -1. The two gradients.
What's that you want to find?
Okay, let's go back up here. It says the two lines are perpendicular, or they meet at a right angle, if their two gradients multiply to -1. So all I'm trying to find here is, are they perpendicular? Yes.
But if they don't equal -1, then
Well, let's go. Let's keep going. Okay, let's see. We're going to get some other options here. So for B, it says y equals 1/2 x plus 2. What's the gradient of that? 1/2. This is stuffed. It's not in the right thing. It's not how I want it. So I got to change it. So if it's not in y equals mx plus c, then I have to make it y equals mx plus c. So what do you do first?
Plus x.
Plus the x. And then divide by 2? Everything. Thank you. Okay, so I've done divide by 2, divide by 2, divide by 2. What about this? Is this? Yeah, it is. It's 1x over 2. So what's the gradient? Half. Okay, now. Is everybody up where I am?
How come the x went in front? I thought last time we did the x.
You can put it in back if you want. I don't care. But I'm trying to make it look like y equals mx plus c, so I put it in front. Is that fair? Okay. These are the same. What does it say up here? Parallel lines have the same gradient.
So they're parallel.
So these are parallel.
Oh, this is actually like a x.
Okay, good. Got it. I've run out of room, girls. Have you run out of room? A little bit? Okay. I've run out of room. I'm going to write on a little sheet of paper, which seems very unfair, except that I do have many of them. So if you need a little sheet of paper, if you run out of room, you can grab one. You can run up and get it. Here I go. Last one. I can come in and explain it to you again after I do these notes because I'm videotaping. Here we go. Okay, I need you to turn these into y equals mx plus c. I'm going to pause. And that's that. And that's that last one, neither.